In this video, I'm going to demonstrate using SPSS to compute a basic bivariate correlation and display data in a scatter plot. So the first thing that we need to do is create two variables, since it's bivariate, and we're going to make these two quantitative variables. And the way we start that, if you've watched the previous videos, is we go to variable view, and let's just hypothetically say that we are going to look for a relationship between the number of books read. Let's say that's the number of books read in a month. So when we define this variable, we don't need any decimals, and we're going to make that a scale variable, so it'll just be a count. And number of books read, and we're going to correlate that with scores on an IQ test, hypothetically. And that'll be a scale variable as well. So if we go back to our data view and we'll enter in some data. So number of books read in a month, we can enter a few data points in here. And we're going to have 20 individuals in this sample. And so the way that the data set is structured in SPSS for a bivariate correlation is that each row is one single individual, and that single individual is measured twice, number of books read and IQ. So participant 1 read 10 books in a month, and this individual's IQ was 112. So in this situation, we have 20 individuals measured twice. One measure is the number of books read, the other measure is an IQ score. So the first thing we can do is, let's say we want to look at a visual display of the relationship between number of books read and IQ. And in most cases, when you have two quantitative variables and you're assessing a relationship, the best way to do this is via a scatter plot. And so if we want to create a scatter plot, there are, again, with SPSS, multiple ways that you are able to do this. I tend to use the chart builder option. So if we go to graphs and chart builder, and you'll get this workspace that comes up. So down here on the bottom, you can see your options for creating a plot. So down here you'll see your scatter dot option, so you click on this, and here we just want a simple scatter plot where when we drag this up and drop it into the workspace, you'll see you're going to have an X variable and a Y variable. Now in correlational studies, usually what you do, you're going to have a predictor variable and a criterion variable. So in this case, we want to know, is number of books read a good predictor of IQ scores, let's say. So normally you're going to put that predictor variable on your x-axis, so you're going to drop it in here. Then you'll take your criterion variable, the IQ, and you'll drop that on the y-axis. Now it's important that we remember that this workspace is just a workspace. In other words, it's not an accurate depiction of the values of your data. For instance, if you're sitting next to a classmate, you likely will have a workspace that looks different than them. All the workspace is used for is to make sure that you are telling SPSS everything that you want in there. So, predictor variable, number of books read, criterion variable, IQ, and over here you will make sure that your statistic that you're showing is the value. So each value in your scatter plot is essentially an X, Y coordinate, basically. So you have your two measures, X, Y, for each individual. So once we've done this, you can click OK, and you will end up, hopefully, if everything goes well, you can see that it's running down here in the bottom right. And this is what you programmed in by point and click. And hopefully you will have a scatter plot show up. There it is. So as you can see, when we look at this scatter plot, in basic APA format, we know we need to change things. So to recap that before we look at what the scatter plot tells us, we're going to double click on it, and we're going to get rid of the title because you will use the figure caption as the title. Notice that when we created the variables, SPSS doesn't like to have spaces, so I used underscores. So in here you would want to delete those underscores. And so we can make this number of books read. And there's your IQ, that's fine. You do need to make the numbers on your axes larger, so we'll click on that. We'll change the preferred to 12. Same thing to be consistent on the x-axis. We'll change that to 12. And then you can do some other things. So first, you notice there are grid lines here. So we want to take those grid lines away. So we're going to go to Options, Hide Grid Lines. And so we need to do that for both of them when it does the double. So we can go and hide those grid lines as well. Now you can note that by default you have this kind of very small gray dot that shows up. Sometimes that's a little difficult to see. And so what we might want to do is click on one of those dots, and then you get the properties window where you can edit those. So I tend to like to make these size 8, and I usually fill them with either black or dark blue, and with no border. So if you click on border and you click this red line, there is that essentially takes a border around it away, and then you can click apply and you'll see those points get larger. So once you've done this, you can close that out, and so now you have your edited plot here. And what you would do is, if you have a Microsoft Word document, you would just right click, copy, and paste that into your Word document so that you could create a figure caption. This is certainly something that your research and analysis instructor will discuss with you. So now if we just look at the scatter plot, this tells us that we, generally speaking, look at this, have a situation where as the number of books increases, IQ tends to increase. So note that the language that I'm using, it's more cautious, and the reason being is when you look at a correlation between two quantitative variables, you are unable to say that one caused the other, but they do tend to covary in a particular way. And so when you have the situation like this, whereas one increases, the other variable tends to increase as well, that's indicative of a positive relationship. Now the other thing that you can kind of get a sense for is you can look to see how well these dots cluster together. And one way to get a really good sense of that is if we double click on our plot again, and if you go up here to the top where you have add a reference line from the equation, this is essentially going to put a line of best fit into your plot. And so when you do that, you see your line, the best line of best fit through your data points. And this can be indicative of how strong the relationship is. So when your points fall close to this line of best fit, the stronger your relationship, and that translates to the better able you are to predict one variable given the other. Now, the further the spread away from this line of best fit, that's indicative of a weaker relationship, meaning you're going to be less accurate in your prediction. So, in order to have the mathematical way of assessing the strength, right, we know it's a positive relationship, but we can tell SPSS to run a basic bivariate correlation so we get the Pearson's R value to have an interpretation from typical benchmarks about the strength of the relationship. And so what we'll do is we'll go to Analyze, we'll go to Correlate, and we're going to go to Bivariate because we have two variables. So when you bring this window up, you're going to take your two variables. Sorry for the phone call there. And you're going to drop those two variables over to the right box. Once you have that in here, by default, you can see Pearson is checked. You may or may not learn the other two options here, but in this video we're only focused on the Pearson. That's going to give us our Pearson's R to allow us to assess the relationship between the number of books read and IQ. Once we click OK, you'll see this output box, and just so we can get acquainted with it, it does contain redundant information. So basically, here on the top you see the variable number of books read, you see the Pearson correlation coefficient, right, the label. This first column is number of books read correlated with number of books read. They're the same values, so it should be a perfect correlation. What you're really interested in is this value here. So number of books read correlated with IQ. This is your R value. So in this case, the R, the Pearson's R for the relationship between number of books read and IQ is 0.662. Now, in terms of strength, depending on the scale that you learn from your instructor in research and analysis, it can vary because there is no hard and fast interpretation, but very basically, if you have a 0.7 value or higher, that's considered a strong relationship. So to keep it simple, this would fall kind of in the moderate relationship level. Some might even call that moderately strong because it's kind of approaching the 0.7 value. Now, another thing that you're going to note in here is that you have a p-value associated with your Pearson's R. So this is essentially giving you some sense, and again, you'll learn this in your research and analysis class. That p-value is essentially the likelihood that you would see this correlation result if there actually wasn't a relationship there. So in this case, it's really unlikely because it's less than 0.05, which is the conventional benchmark for interpretation of significance. But it's very unlikely that I would get a correlation of this value or of this strength if there actually wasn't a correlation going on. So this would be a statistically significant correlation, and it's a moderately strong correlation. Hopefully this helps you get acquainted with conducting bivariate correlations in SPSS.